For centuries, we believed the quantum realm was a fragile, icy domain, a ghostly world confined to sterile laboratories and supercomputers. But we were wrong. Birds navigate using quantum entanglement in their eyes. Plants feed themselves by mastering quantum coherence. And your very own nose might process the scent of a morning coffee using quantum tunneling. Welcome to the wild, impossible frontier of quantum biology. Nature hasn't just been ignoring the classical rules of physics, she's been cheating them for billions of years. Every morning, the greatest magic trick on Earth begins: photosynthesis. But down at the molecular level, this isn't just chemistry, it's quantum mechanics at room temperature. When a photon of sunlight hits a leaf, it creates a packet of energy. This energy needs to reach a reaction center to be turned into food, but the path is a chaotic, microscopic maze. If it bounces around blindly, the energy is lost. So the plant uses a quantum loophole, superposition. The energy wave exists in a state of quantum coherence. It acts as a probability wave, exploring every possible route simultaneously. Once the most efficient path is found, the wave collapses. The plant isn't just catching light, it is running a quantum computation. If plants are quantum computers, migratory birds are quantum astronauts. Every year, millions of birds fly thousands of miles across featureless oceans, guided by an invisible map. Deep inside the bird's eye lies a light-sensitive protein. When a single particle of light enters, it knocks an electron away from its partner. This creates what physicists call a radical pair. Though separated, these two electrons share a miraculous connection: quantum entanglement. What happens to one electron instantly affects the other, no matter the distance. Together, they form an impossibly sensitive compass. As the bird flies, the Earth's weak magnetic field alters the spin of these entangled electrons, painting a literal magnetic heads-up display over the bird's vision. They are seeing the quantum fabric of the Earth. But you don't need feathers or leaves to tap into the quantum realm, you just need to take a breath. For decades, we thought smell was just a matter of shape. A scent molecule fits into a receptor in your nose like a key into a lock. But there's a problem. Many molecules have different shapes but smell identical, while others have identical shapes but smell completely different. The secret isn't shape, it's music. Enter quantum tunneling. In the microscopic world, particles like electrons can pass through solid barriers like ghosts passing through walls. When a scent molecule enters your nose, an electron tunnels straight through it. If the molecule vibrates at the exact right frequency, the electron completes its jump, triggering the nerve. You aren't just smelling a chemical, you are smelling its quantum vibration. The deeper we look, the more we realize that life is a master of the quantum arts. Even the very blueprint of who you are, your DNA, is held together by quantum glue. The rungs of the DNA ladder are held together by protons, but in the quantum world, protons aren't solid objects, they are shimmering waves of probability. Sometimes, through quantum tunneling, a proton will spontaneously jump across the rung to the wrong side. If the DNA unzips to replicate while the proton is on the wrong side, a mutation occurs. This quantum glitch is thought to be one of the invisible engines of evolution. The diversity of life on Earth might be the result of a microscopic roll of the quantum dice. For a long time, we viewed biology as a clumsy, chaotic machine made of gears and levers. But nature is far more elegant. Life operates on the absolute edge of physics. It plays the quantum symphony, utilizing the weird, the impossible, and the invisible to survive. We are not just living creatures. We are quantum masterpieces.